Daryl here. The channel is Programming in Any Language. The supporting website is www.black-duck.com. You'll find the videos and PDFs of the code there in most cases. The video is the Anything Database version 2, Part 1, Planning and Design. As a consultant, I quickly learned that while my clients' needs varied, they all wanted the ability to create collections of data and then be able to save, load, edit, delete, and search that data. This made things easy for me. I only had to create one application that did this. For each new customer, all I had to do was modify or tailor what I had created for the first customer. My application was actually a blueprint for all the ones that I created later. When I came to teaching classes, I replicated that user need to the Anything database. The Anything database is an application that gives the user the ability to create a collection of data and then save, load, edit, delete, and search that data. The version of the Anything database that we're about to create in this text processing section is going to store the data in a collection of lists. It's also going to use text processing to format each field of data to a specific size so that it can easily be ported to a database engine or a spreadsheet. Building this application is complex, but by breaking the parts down into manageable pieces, you'll find the application is not difficult. Oh, you can make it difficult by trying to do it all without much of a plan. But you'll quickly see that building small parts and connecting them is much easier than trying to do it all at once. This application will be broken down into 9 parts. They are analysis and design, adding records, navigation, saving records, loading records, editing records, deleting records, clearing the file, and searching records. We'll start with part 1, analysis and design. Once we've looked at text processing and discovered all the things we can do with it, the character, the substring, the contains method, all the different methods we have in this thing, we're now prepared to do a lot of different things with our programs. We're now in a position where we can do some pretty sophisticated programming, and that includes working with databases. We're not going to work with a database as such right now, but we're going to look at what a database is and understand how we can use programs, different applications, to create data that's going to work with databases. And that's what the Anything database version 2 part 1 is all about. This first piece we're going to be doing here, planning and design. I need to show you what we're going to actually accomplish, what we're actually going to build to begin with. To start out with, we need to understand databases. We haven't touched that so far in the website, but we're going to touch on it today a little bit. With a lot more to learn about it, but I just want to cover what it is so you have an idea of where we're going to be going with our applications. And a database management system, a DBMS, is software that manages large collections of data. Data that's stored in a database is organized into tables, rows, and columns. You can see something down here looking just like that. It looks like a spreadsheet, doesn't it? We've got our columns and rows here. We've got all our guys here, Daffy Duck, Tweety Bird, all that kind of stuff is sitting down here. Each column is also called a field. So we've got these fields here: first name field, middle initial field, last name field. Each row is a collection of related columns. You can see that Daffy M. Duck, 443 Pine Lake Road, apartment 999555, Pine Lake, California, 90343. These are all related to Daffy Duck. And it has an index of 2 on it. And here's the Elmer Fudd. All of these particular pieces, fields inside the row, are related to Elmer Fudd. They're all contained there. Yet we have these fields there. So each row is a collection of related columns. Each row typically is assigned an index making it unique from any other row. So you can see 2 Daffys here. They're very similar, but the fact that we have an ID 1 and an ID 2 here, they're very different. And we could use either one of these records, so we can have a difference. So we have differences like that. If you work with a company and you're creating names of employees, you might have Tom Smith several times in there, and something's unique is going to be in there, maybe a social security number or something like that. But likely you give people an ID number for their in the company, so that they are unique. Each field of size is a set size or data type. We're looking at here, in this case, we've got all strings here. In fact, this zip code, this is a string also, because we're not going to do any math with these numbers. So these are strings. They're all strings, but they're all a certain size. Daffy, the first name field, is maybe 20 characters long. The middle initial is maybe 1 character long. The last name field is maybe 20 characters, something like that. The address might be 35. So If you exceed the size of the field, the database will truncate that data. So if you enter an address longer than 35 characters long, only the first 35 characters are going to go in this field. And so we use text processing then to make sure that our programs do have just that amount of data in there. So that we're padding it nicely and we can actually see our data and it's going to fit nicely into the database. If you look at a design, this happens from an Access database. We created something that has the first name, middle initial, all these different fields have names in them. And they're all data types of short text, strings basically. What's interesting about this first name field, it's 15 characters long. The middle initial might be 1, last name might be 20. They're all different, but you can look at the size, and you can also apply rules to these fields so that they behave in certain ways when you actually work with it. The thing, though, is that you cannot exceed the size limitation of 15, which we're giving it. We can make this bigger if we wanted to, but when we set up our database, we set it up where we think it's going to work best, or the database manager sets it up where it's going to work best, and then that's what we adhere to with our programs or applications that work with the same database. When working with an application that receives or prepares data for a database, we use text processing methods to format the data to the correct sizes. Keeping a reference of the field names and data types and sizes greatly helps the programmer no matter what language is being used for the application. I'll typically do this. I'll have all those fields identified with their names so I know what I'm calling them in the database. I'll know the data types here, and I'll know what their size here. It's helpful for me to have this on a piece of paper next to on my desk, so that when I'm writing my programs, I know what I'm dealing with, and I don't have to go looking it up all the time. And it also helps me when I build my text field names or my string names or my memory names or my array or whatever I'm using. I can use things like first name, maybe put txt in front of it, txtmi, or str if I'm using a memory location. So I can have the same name very similar to what I have in the database, so I know what's going into where when I'm actually working with it. It takes out a lot of that confusion away. Now let's take a look at an application. Collecting data for a database can be accomplished by creating an application that collects the data and saves it in a text file. That's what we're going to do. We're going to create an application that saves the data into a text file, but allows us to take that text and move it into a database whenever we feel like it. Databases will allow you to import data from various sources, and a text file is one of them. So we can actually save that. So by creating an application that pulls in all our data here and allows us to work with this thing, we can save it into a text file and then bring it into the database. Using text processing methods, the data can be captured with the correct data type and size for each field. So we're going to control that here. We're only going to allow Daffy to be so long, or the first name to be so long, the middle initial to be 1 character, duck to be a certain character long, the addresses and all this. We can all control that here. That when we port it out, it's all set for the database. We don't have to worry about dealing with the sizes. And you can see that here. If our application were to create our text files according to our database, we'll see Daffy in a bunch of space along with a comma. We're creating a comma delimited file here. M for middle initial. Duck is the last name is so long. We're padding with blanks. We have the 35 character Pond Lake Road, 443 Pond Lake Road sitting out here. The apartment, the address line 2 is sitting here. The city, the state, the zip, all sitting in here. And you can easily then import them into the database. So the first name is going to fit nicely into here. The middle initial is going to fit nicely into here. So will this. And we can bring all that in to our database and make it work. But the thing is, we can also keep it in this text file until we're ready to port it out to a database. It can also be ported to a spreadsheet, a CVS file. And you can bring this data into a spreadsheet very easily because it's comma delimited. There's a lot of functionality that goes into a program like this. In fact, the program we're going to build, the application we're going to build, is something that I learned when working with users in my consulting days. They all need something that's going to work like this database, like this application is going to work. We need to bring in data. We need to navigate that data. We need to be able to change it, edit it, delete it if we have to, print it, save it, load it, all those kinds of things. And it turned out that every time I built an application like this, it was very similar to the application I built before, but for a different customer. So really, once I had a model going there, it was nothing more than doing the same thing over and over for different customers, but changing the names of the fields, changing the sizes, talking to them and building it, tailoring it for them. But a lot of the beginning work, the design work was all done with the first application I did. So when we build this application, we want the Anything Database version 2, we need to create a hierarchy chart, identifying the functions and methods we want for this application to perform. So we want to do some thinking ahead of time, figure what do we need it to do. It's a little upfront work. We also want to be able to design a form so it's pleasing and functional for the user. We want to write the code for each function and method. That's our coding piece. And test the program, correcting any issues. We're going to spend a lot of time creating this and then designing the form. That upfront work you've done here makes this writing the code piece a lot easier. You're not going to have a lot of testing to do once you've got, if you did a lot of good work up front here in creating your application, designing it, your code is going to be a little bit smoother to write. And the testing is going to work pretty well. You're going to find a few bugs in there, but you'll fix them. If you don't do a good job up front here, you're going to spend a ton of time testing the program and correcting a ton of issues. And we do that by creating a hierarchy chart of what that's going to do. There's our add, our edit, our search, our clear, load, save, delete, and navigation. And we also got update and cancel and find in here too, which will be part of the functionality. So when we start thinking about it, we want to be able to navigate through the records. That means going to the top, bottom of the file, going forward, going backwards. And each time we do that, we want to display the results so we can see what's out of the file at any given time. We want to delete a record. So if we're sitting on a record, we want to delete it. We want to do this functionality here. We want to add a record. We add it, and we do some updating or canceling if we decide not to add it. Same with edit. So this looks very complicated and complex as to what we've all got here. But by putting this up front, and this does not have to be perfect, by the way. When you're writing applications, you'll often forget things or miss things or whatever. This is simply a table or a chart or a roadmap to allow you to get started. And as you encounter things that are missing, you can easily put those things in. In fact, in putting this thing together, I found things missing that I had to add to it just to get this thing right or add more things to it. And I'm sure there's things missing yet that we'll accomplish as we go into the coding portion of this feature. We've got all this stuff to do. That once we do this, we can kind of give an idea that, well, we want to add, edit, delete, clear, load, and save. We can probably put this on a form as to how we want to actually build this. So we end up building our form. And our form might look like this. And I've created this so we've got some text names in it. So our fields are all named. You'll notice that we don't name these things. Name number of records is simply a string that's put on a label. We're not going to access and code, so we don't need to name this at all. Same thing with first, MINL. The other things we do need to name. These fields in here, Daffy, 443 Pond Lake Road, where all is all going to sit, the state, the zip code, a field to do searching on. We put all those things in here, and we name them with our text names. TXT last name. Last name is what we call it in the database. TXT last name is what we're going to call it in the application on the form. We might call it STR last name inside our file and make it work like that. So all these pieces are put in place. We've got all these buttons that we're going to work with. We've got a couple buttons hidden too. We've got an update and a cancel button sitting behind the edit update because we're going to make these all disappear when it's time to update or cancel. We don't want the user to be able to load a file when he's in the middle of an edit or in the middle of an add. So we want to be able to control the user somewhat and allow them to work properly with this thing. We've got our buttons sitting here, and they're inside a navigation panel. And the reason they're inside a panel is we want the panel to be invisible if there's no records out there. We can't navigate when we don't have anything out there. We need to do a load or an add to get some records out there. Once that's done, then we can actually navigate and turn this on so we can actually see it. So there's a lot of things to consider when we're actually working through this thing. And as a new programmer, you might not realize all this stuff and you end up covering up and testing and debugging. But looking at it up front, those things will exist and we'll kind of step through that. Looks complex, and it is complex, but it's not complex when you take it a piece at a time. In fact, that's what I've always told my students, is that programming is very, very, very easy. The difficult thing about programming is all these easy things, there's so many of them. That's what gets you confused. There's a ton of easy things to do, and so your mind gets wrapped up in what do I do first? What do I get going on? No, so before we do any of this application work, we need to understand the hierarchy chart and then build the form. So let's try and do that. So I've got a form sitting up here right now that I'm going to use for my Anything Database version 2. I've set it up to be a width of 687 and a height of 360. I'm also going to go up here into the form itself, and I'm going to change the name on here from Form 1 to the Anything Database version 2.0. This will be an application that's going to use a list. What I'm going to do with this particular thing right now is put on all those pieces that we saw in our graphic before in the slides and make that all happen. So what I'm doing here is I'm putting in all those pieces we might have seen before, and I've got those in place, and I've got them named already. You can see the number of records, again, has no name. It's simply a label 1. Same with first. Same with navigation. You can see the panel now for the navigation. If I click on the panel, you can see it's called panel navigation. You can see that each button here is called button back, button top, button forward, and button bottom. I'll need to place the arrows in there as well so we can put that stuff in place. We also have the names of the field. We have text first name, text middle initial, and this is text search name. I'm going to put this to the back, so I'm going to right click on this thing and send it to the back, because we're really going to be having something called text last name, as you can see here. The search box we're using in here will be used in the very, very last function. We actually want to use this as a search tool. When we click on search, we'll be able to type in a name, and then it'll search the database for us. Right now, we're going to basically, you don't have to add it to the form right now because we're not going to get to that till later. So right now, I'm just using the text last name field here. I've got an address, text address line 1, address line 2, and address line city, state, and zip. And I have my buttons, button add, button edit, button delete, clear, search, load, save, and exit. And behind edit, I'll send this one to the back, we've got the update button. And over here we've got if I send this to the back, we've got the cancel button. So those things are there as well. Now, how is this happening? Well, these are invisible. If we look at the update button, for example, the visibility is false on this thing. Same with the cancel button. Not so with clear, or with add, or with edit, or delete. Those are all visible, so we're going to see those things. And we'll have a routine that's going to reverse these things so that the visible ones become invisible, and the invisible ones can become visible when we're working with certain functions, and you'll see how all that happens. Same thing's happening with this panel. The panel also is invisible. So we can't see these navigation buttons when we start up the program because there's nothing there to navigate. So we don't need to deal with that at all. And we'll put the arrow pieces in this thing when we get to the navigation piece. We're not going to do that right away. We're going to have to add some records to this thing first. The other thing we're noting here, I did change the font sizes and all these things so that it'll be easier to see, but every one of these fields here, we look at the name field, for example, has a max length. As you can see, 15 for the first name. Middle initial has a max length of 1. 20 for the last name. 35 for the address line 1 and 2. City has a 25. State is 2. And zip is 5. So we have that all there in sizing so that we can't type in anything beyond this. That's going to stop the user right away from making it too large. And I don't believe we have tab indexes also set here. So if we look at the tab index on first name, we'll see it's a 49. Middle initial is 50. 51 for last name. 57, 58, 59, 60, and 61. So when I set a focus to the name field, if I tab on it, it's going to automatically go to the next sequential object and so on. So we will type nice straight through this thing. Yeah, they're not named 1, 2, 3, 4, 5. That's because the tab indexes are also sitting out here for first, middle initial, and last. But these are labels, so it never uses those. So it doesn't make any difference. You want to take the time to change these things to 1, 2, 3, 4, 5, 6. That's fine. You can do that. But I'm confident this is going to work and tab nicely for me as I go through this. The other thing about these text fields here, the enable property is set to false. The reason for that is we don't want to type into these fields unless we are asking ourselves to type into this field. What will allow us to type into it? The add button or the edit button is going to allow us to change things. So we want to be able to just view in here and not make any changes to the data unless we intentionally tend to create something. So we set them as for enabled false so that we can't use that until we actually have to. So we've got this all in place. We're going to have a place where we're going to talk about how many records we have. That's always going to be displayed up here. Our buttons are set to go. Our navigation is all set. The only thing we need to do now is create some code. And we're going to go into the exit button, which is named button exit, and lay our first piece of programming in here by simply saying close form, this close, and that makes it all happen. Do a file save on this real quickly. Do a run. And you can see our application comes up. You cannot see any navigation. The fields that are going to hold text data are basically, you can't even type in there. They're just simply put away because we haven't turned anything on. Our buttons are all here, so we can do all this kind of stuff, but that's all that's going to happen at this point in time. Now, one of the other things we can do, we're going to have to store the data here, so we can prepare where we're going to actually put things. And so to begin with, we're going to go up into our form up here, and right in this section, we're going to start creating some global variables that are going to be constant for us. Not constants, but constant for us. In other words, we're going to be using these things in different applications, different pieces of the application. We're going to set a record count and make it equal to 0. We have no records there. That's what's going to display on the screen. We're going to have the record pointer equal to -1 because we're not pointing any records right now. And so if we're working with lists, -1 is going to mean we have nothing there. We're not pointing anything. The next thing we're going to do is create our list. For now, we're going to use a list for each of the fields in our form. In other words, when we look at the first name field, we're going to create a list for this, a list for this, a list for this, and so on, so that our index is always going to point to all of the records you're seeing on here. It's kind of like looking at that database we saw a little while ago, where you've got different fields, but they're all related with an index. So index 0 is going to be the first name. Index 0 for the middle initial is going to be the first person's middle name's middle initial. The last name for that first person is going to be in here as well. So we do that by setting up our list. We'll place that right in here. We'll call it a list, all strings, LST first name. Notice LST first name again. The same name that we called it in the database. The same name we called it in the form, text first name. We're going to call it list first name. And it'll be a new list string. Middle initial, last name, address line 1, address line 2, city, state, and zip. All these pieces are there. So we're creating 1, 2, 3, 4, 5, 6, 7, 8 lists. We're also going to want to have data entry variables. When we bring in our data from the screen, we're going to be bringing in the first name, middle initial, last name, address, and all that. Again, the same name with the data type in front of it, str, it's a string, first name. So that's how we're going to handle these things. So we're keeping first name across the board, so it's very easy to know where this thing goes from when it goes to a database, or when it goes to a list, or when it goes to the text box, or when it goes to memory. The other thing we're going to do is, since we're doing text processing, we're going to be wanting to do some work with each of the fields to make sure they're the same size. And we're going to do that by always appending a set of blanks. I've got 35 blanks sitting right here, which can be appended to any one of these strings, and then we take a substring of it for the size we're actually going to be putting into the list. So in other words, if somebody types in Daffy up in here for the first name, we can concatenate Daffy with this 35 blanks here, and then take a substring of 20 positions from 0 to 20 to actually put a 20-character field into the list. That way we're always creating the same size last name, first name, middle initial, across the board, so it fits into our system very nicely. That's what that's there for. So those are all pieces we're going to be using for our database when we work on this thing. So that's where it stands to begin this thing. The next thing we'll do is we're going to actually go ahead and create our first record, and that'll turn on all kinds of things. So right now we're sitting like this. If you look at our form, everything's there. We know we've got our memory sitting out here. We're not showing anything in the label right now because we haven't done that. We could certainly do that in form load. In fact, let's do that in form load real quick. Can we do that in form load? I think so. Let's go ahead and code that right away. We do that by simply going to a blank piece on the form, double clicking on it. We've got our form load sitting here. And what we can do is, since we have no records, we'll set record count to 0 and we'll put it out into the label. Save all, run the thing again. And our program is starting to come alive. It's showing number of records 0 in this database program we've got here. So nothing's there. What we'd like is to be able to add. That'll allow us to fill in all these things in here and actually save a record into our list database. And once we've got that, that'll turn in the once this is above 0, this will turn on the navigation window, allowing us to navigate through all the records we'll have in this database. Obviously with one, we're not going to go very far, but if we add more, we'll be able to navigate through it. So that's what we're going to do next. We're going to look at the add button next. All the pieces are in place. Design is important. If you forget something, that's okay, and it's normal. You can still add it. but the foundation looks to be in good shape. We can start programming. And we'll do that in the next video as we create the functionality to add records. Thanks for watching. Visit the website when you get a chance. And please subscribe to the channel. There's more stuff coming every week. We'll see you in the next video. Take care.